All right, good morning. Welcome back. I hope you guys are all doing well and staying safe. I also hope you had a good day off from chem class yesterday. Good day off. Beautiful day for you out there to enjoy. Little heads up, it's going to be pretty nice the next week as well. So next coming week is going to be really nice. So hopefully you get out there and enjoy this weather too. All right, there's not a big class today. I only have like 6 people online or in class total. But we're gonna still have class. Here's a 7-day forecast. Just a little heads up. 84 degrees today. You can see what's ahead. Maybe a little rain on Saturday, Sunday, maybe Friday, Saturday, Sunday. But still awesome. If you're working at a ice cream salon, ice cream restaurant, ice cream parlor. Working at an ice cream parlor is probably gonna be busy this next week. That's good.
Of course, it's the highest day.
Yep. Be busy tonight, I'm sure. So yeah, find a routine. Go out for a walk, go for a run, go for a bike ride, whatever it may be. Just get out there and enjoy this weather. Been waiting for this for a long time. So nice forecast coming on up for this week. There's some people taking the AP test. If you're taking the AP test, good luck. Hopefully you did well. Hopefully you're re-watching this video and see what's going to happen for today. Real quick, there's my attendance. Looking for Alex, Alan, Michael, Leo, Kim, Santino, Nadina, Joey, Jumila, Emma, Bellman, John, Tintin, Frank, Nidal. It's right on board. Irvin, Wendy, Jordan, Philip, Ryan, and Faith. If you're not here, please, if you're here, please let me know. Hey, Leo. Stayed home today. It's a beautiful day. All right, so anyways, let's start fresh. Please check out this video. If you're taking the AP test, please check it out, and you'll see what's going to happen for today's class. The show must go on. All right, welcome on back. Quote of the week comes from this guy named Mr. Brown. He says it all year. I don't know if I didn't coin this phrase, but I say it all year long. Whatever you put into something is what you get out of it. This class, whatever you put into this class is what you get out of this class. If you are engaged with the lessons, if you copy your notes down, you understand the examples, you'll understand the exit pass, you'll understand Regents chemistry. If you didn't put much into this class, you didn't do your guided notes, you didn't do the examples, then you can't expect to get anything out of it. Same thing's true for your relationship at home with mom, dad, or grandma. Maybe you have a boo. If you put something into it, whatever you put into that relationship is what you get out of it. You put effort into that relationship, you'll get something out of it. Your job. If you're working your tail off at your job, you're putting the effort in, you're doing what you're supposed to do, you'll probably be rewarded with more hours. Whatever you put into something is what you get out of it. Today's Wednesday, May 19th, 2021. It's a day 2. We are going to do unit number 10, organic chemistry today. Second half of class, we'll do that. Hey, Ryan. We'll start off with post-test review. The post-test for unit number 5. We'll go through chemical bonding. And then we'll jump into topic number 4, naming organic molecules. So naming organic molecules, we'll figure out some examples. We'll figure out the guided notes. We'll copy all that stuff down so we know how to name these organic molecules. We will not have time for 3, 4, or 5 today. Just a little heads up. We will not have enough time for 3, 4, and 5. So the only thing we're doing today is reviewing Unit 5, chemical bondings, and we'll start to go through organic chemistry, naming organic compounds. Little heads up for the post-test. The post-test is 32 multiple choice questions. The post-test will be graded. It's counting as a test grade. And your post-test for science is going to be, for chemistry, is going to be May 26th. So next Wednesday is when your post-test is going to be. I understand there's going to be other tests there. Probably math tests. You could potentially have a business test, a English test, a math test, phys ed test, social technology, world languages. But there's only 1 week when we could give the test. next Wednesday, your post-test will be for Regents Chemistry. What's going to be on the post-test is going to cover anything from unit number 1 all the way through unit number 10. So stuff today in class, naming organic molecules will be on the post-test. Sig figs will be on the post-test. So unit 1 through unit number 10. If you're checking out the units left for this unit, we can see over here, other side. Unit number 10, functional groups and organic reactions, they will not be on the post-test. So those last 2 topics there, the question marks, they're not going to be on there. Hey, Alan, welcome. Any questions about the post-test? Oof. Oh, that's a tough one. It's going to be graded. And I don't know, I cannot really monitor at you guys at home and what you're doing. I would encourage you to not have your notes with you. I would encourage you to try your best on this. It's a different world we're in. I can't watch what everybody's doing at home though. Okay? If you're in person for the post test, you just have the Chromebook, you have a reference table, scrap paper, calculator, that's it. So if you're in person taking it, I'm gonna watch, make sure you're not cheating. I'm gonna encourage you not to cheat. It should be an assessment whether or not you learn something throughout the year. I would act as if this is my Regents exam. Did you learn anything in Regents Cap? Technically, it should not be an open book. I don't know if that's what you wanted to hear. All right, let's just get right to it. So open up the guided notes for unit number 5. And let's open up the review for unit number 5 too. So find the review. Unit 5, chemical bonding, is a big unit there. 16 questions we're going to start for today's class for you reviewing unit number 5. So unit number 5, chemical bonding, this unit took us forever to get through. Why? A lot of topics were in this. We started this on November 30th, and we went through ionic bonding, went through covalent bonding, metallic, hydrogen bonding, all that stuff. There's 30 pages of notes and examples within this packet. So by now you should have mastered unit 1, science is a verb. You should have mastered matter and energy, unit 2. Unit 3, we already went through the atom. You should have mastered that with the notes. And unit number 4, you should understand everything with the periodic table. Unit number 5, this will put us halfway throughout the year, chemical bonding. So tonight, I would focus on maybe reviewing your notes again, checking out your exit passes for the entire unit. So here we go. We talked about ionic bonding. When we did this, we start off with ion formation or ion review. We know what an ion is. An ion is an atom with a charge. Why is it charged? Because it either lost or gained some electrons. We represented nonmetals with a negative charge. We know that has a negative charge, meaning it gains some electrons. And metals, they have a positive charge, meaning they lost their valence electrons. We represented those with electron configuration. We figured out which noble gas is most similar to the ion. We named some ions. Hey, Alex. We named some ions here. Within the ions, we named positive ions. We named negative ions. Metals. We named the metals. If there's only one charge listed, it's just to name the element. But when there's more than one charge listed, you had to indicate what charge it is with a Roman numeral. We talked about naming non-metal ions, taking the first syllable, like chlorine. First syllable is chlor, and you add ide, chloride. Oxygen, take the first syllable, ox, ide. Carbide, nitride, bromide. We did all that. We talked about types of bonds where they share or transfer electrons. We definitely went a lot further in detail than just sharing and transferring. Probably taking the AP test, Alex. This concept right here we should be aware of. I know there's a question similar to this on the post test. Forming and breaking bonds. So there's definitely a concept similar to this on the post test. You have in the notes. Forming a bond is exothermic. It releases energy. How do we think of this? We take two atoms, atom A, atom B. They're separated. But when they form a bond, they come together and they smash. As they smash together, what happens? It gives you a collision. That collision provides some friction, some heat. Heat is released when atoms come together. Two atoms come together, they collide. Heat is released. It's an exothermic reaction when you form a bond. If you break a bond, it's going to be the opposite. Breaking a bond, endothermic reaction. We talked about types of bonds. Ionic bond versus covalent bond. We represent the Lewis dot diagram for an ionic bond, Lewis dot diagram for a covalent bond. We know an ionic bond is a metal and a nonmetal. They transfer electrons. An ionic bond represents the ions, the charges, with the electrons around the negative charge. Negative charge has all 8 electrons around it. The positive has none because it lost the electrons. We represent covalent bonds, 2 nonmetals sharing electrons. We didn't put brackets there. No charges we represented. We could identify ionic versus covalent bonds. We talked about Leo says Ger with exchange of electrons. We did a Bohr diagram and a Lewis diagram. We did some ions. We talked about properties of ionic bonding. We said metal and a nonmetal bond together. They transfer electrons. And their electronegativity difference is greater than 1.7. Electronegativity difference. We subtract the 2 values for electronegativity, the attraction for electrons. If the value is greater than 1.7, it was proof it's an ionic bond. Identify an ionic bond. Is it a metal or a non-metal? Once that's done, check out the change or difference in electronegativity. We named, or we took some ions and we came up with a formula. We took 2 elements, a metal and non-metal. I came up with the formula. From the 2 elements, we have the 2 charges. You found the charges on the reference table. We took the 2 charges, right, Joe? Took the 2 charges and took the absolute value and crisscross those charges. Take the 2 charges, put them on up there, top right corner. Take the absolute value and crisscross those charges to give you a formula. We did that. We did that for binary compounds. We talked about ionic properties. A metal and a nonmetal as a liquid can conduct electricity, but as a solid, they do not. We talked about topic 3, naming and writing ion formulas. More crisscross method for figuring out an ionic formula. We did that for binary compounds. We went from a formula to a name. We identified a formula to a name. We took the ion naming system and we named them. Positive ion, negative ion. If there's more than 1 charge listed on the reference table, you had to indicate it with a Roman numeral right there. Nonmetals, bromide. First syllable, ide. Hopefully you remember how to do that. We went from a name to a formula. We showed you how to get there. We talked about ternary compounds. In ternary compounds, we went from a name to a formula using the polyatomic ions on page 2 of the reference table. We said polyatomic ions are going to be in parentheses. And then you have to take the charge and crisscross them to get the formula. Hopefully you remember talking about this. We went from a ternary compound, a formula, to a name. Hopefully you can do that still. We talked about types of formulas. We said a chemical formula, compound. We talked about molecular formula. We did in this unit too. Molecular formula tells you the total number of elements and the elements in a bond. The empirical formula is going to tell you the simplified version of the formula. So empirical, molecular is total number. Empirical is going to be the simplified version. Hey, Micaiah. The structural formula shows you the shape of the atom, shape of the compound. We talked about the ball and stick model shapes. Don't stress about that too much. Then we talked about number of moles in a compound. You should know how many CAs are in this compound, or N's or O's are in a compound. We did that, easy. We talked about coefficients, how to distribute the coefficients to figure out how many moles of each element in a compound. We talked about GFMs, gram formula masses. Hopefully you know how to do that still. We'll practice one today. We talked about GFM of a hydrate. We talked about number of moles, how to calculate number of moles, given mass over GFM. There's a couple examples there too. And then we talked about percent mass of a hydrate. How much water is trapped within a compound. That was all ionic bonding, within ionic bonding unit. We talked about chemical reactions. We said two atoms come together to make a compound is addition or synthesis. We said decomposition is breaking up of a compound to smaller things. Single replacement or substitution was an element plus a compound yields an element plus a new compound. Double replacement's a compound plus a compound yields another compound plus another new compound. We talked about combustion too. Water and carbon dioxide were the products. Other chemical reactions we talked about in this class were neutralization. An acid plus a base yields salt and water. We also talked about redox reactions. So those reactions you should all be familiar with. We talked about how to balance a chemical reaction. What's on the left side equals the right side. Must obey the law of conservation of mass, energy, and charge. Now we're on page 23. We talked about covalent bonds. We said they're two nonmetals. They share electrons. They cannot conduct electricity because they're nonmetals. And the electronegativity difference is less than 1.7. We talked about nonpolar covalent bonds, where there's no pole of electrons. Nonpolar covalent bonds, the difference in electronegativity is 0 to 0.3. Electrons are shared equally. They're symmetrical. And we represent some examples for nonpolar covalent bonds. You should be aware of how many electrons are shared in a single covalent bond. You should be aware of how many electrons are shared in a double covalent bond. You should be aware of how many electrons are shared in a triple covalent bond. On a stick, there's going to be an electron on each end of the stick. Single covalent bond has 2 electrons shared. Double covalent bond has 4 electrons shared. Triple covalent bond has 6 electrons shared. Should be aware of that. We drew some nonpolar covalent bonds with Lewis dot diagrams. They're all symmetrical. We talked about polar covalent bonds. Has a pole, 2 nonmetals sharing electrons, but someone's being a hog and stealing in those electrons. There's an unequal sharing of electron. The electronegativity difference goes from 0.3 to 1.7. And then we talked about partially positive, partially negative, but you don't have to worry about that for this course. We did some examples of a change in electronegativity difference. You saw that they're all within that window for polar covalent bonds. We drew some molecules. And then we talked about naming covalent bonds. We did several examples there. We talked about metallic bonds are 2 metals bonding together. It's easy to steal away electrons for a metallic bond. Metallic bonds, 2 metals bond together, they're definitely going to be good conductors of heat and electricity. There's a low intermolecular force. We said hydrogen bonds have a high or strong intermolecular force. What's that mean? The attraction for electrons is strong. It's tough to steal away or tough to break the bond. What creates a hydrogen bond? We said no other fools. What creates a hydrogen bond? No other fools. Nitrogen, oxygen, fluorine. Nitrogen, oxygen, fluorine. Held together by the strongest intermolecular force. Last page, page 29 in the notes we talked about. We said the types of chemical bonds. This would be like our little cheat sheet for the entire unit. Types of bonds. We have the difference in electronegativity. From 0 to 1.7, those are all covalent bonds, meaning they share electrons. We have nonpolar covalent bond from 0 to 0.3. There's no pole of electrons. 2 nonmetals, they share equally, share electrons equally. There's a high intermolecular force, and they're symmetrical. Polar covalent bonds window, the range is 0.3 to 1.7. This means it has a pole. There's two nonmetals. They share electrons unequally. And they're asymmetrical. And ionic bonds of metal and a nonmetal, the difference is 1.7 or greater. They transfer electrons. They can be binary or ternary, and there's a low intermolecular force. Oof. That was it for unit number 5. That's all we talked about. Told you, it took forever. That unit did take forever because there's a lot of information within it. All right, let's review this. Here we go. There's 16 questions on unit 5, chemical bonding review. Please open it up. Let's go through this. A lot of this is going to be like me reteaching things or going through it, but please respond with your answer in the chat if you think you know the answer. All right, here we go. Question number 1 says, which pair of elements forms an ionic compound with each other? We're trying to figure out which one's an ionic bond. So ionic bond in this situation, ionic bond, look below. Ionic bond's a metal and a nonmetal. Which ones have an ionic bond? I definitely would have a periodic table out in front of us. Ionic bond, a metal and a nonmetal. Let's locate it on the periodic table. So find K and find Cl. All right, K and Cl. K is to the left of the staircase. It's a metal. Cl is to the right of the staircase. That is a nonmetal. We by now know that the staircase divides the metals and the nonmetals. Everything to the left is a metal, except for H. Everything to the right is a nonmetal. K and Cl, we have a metal, we have a nonmetal. Looks like an ionic bond. So I would put metal, nonmetal. Probably going to be an ionic bond, but let's check the rest of these. Next up, we have I and Cl. Oh, I, nonmetal. Cl, nonmetal. Two nonmetals, that would be a covalent bond, not choice B. Next up, let's check out choice C. PCl. P, nonmetal. C, nonmetal. Two nonmetals together, again, that's a covalent bond. And last choice is HCl. Find the H, find the Cl. HCl. Oh, H is to the left of the staircase, but it's isolated to the top. It's not connected to group 1. It's kind of by itself. That's the only element to the left of the staircase. That's a nonmetal. And Cl, we saw a few times, that is a nonmetal too. Two nonmetals bond together, covalent bond. One, the best answer is going to have to be a metal and a nonmetal. KCl is an ionic bond. Next up, number 2. Which Lewis electron dot diagram represents the bonding for potassium iodide? Potassium iodide. All right. Potassium. What the heck's potassium? Check on the reference table. Next page, you can find the abbreviations for the symbols. You can figure out potassium is going to be K. So it's definitely going to be that K. And iodide is going to be an I. Can't get rid of anything yet. If I'm looking at this, we have K and I. It's a metal and a nonmetal. This is going to make an ionic bond. Metal, nonmetal, ionic bond, I think of ion. What's an ion? It's an atom with a charge. Why? It either lost or gained electrons. Ionic bonds must have charges represented with it. The ion for K is going to be +1. The ion, the charge for I, the first one listed, is going to have to be a -1. If you look at that right there, you can definitely tell choice A is going to be the best answer. But let's take it one step further. One step further, I do want to represent the Lewis dot diagrams for K and I. All right, K originally has how many valence electrons? Check it out. There's 1 valence electron. And I originally has how many valence electrons? It's in group 17. It's going to have 7 valence electrons. When these two things bond, they want to get to a stable octet. When these two things bond, what's going to happen is a K is going to transfer its electron. It's going to bond right there on I. So what's going to happen? That electron is going to migrate on over, and it's going to lock in right there. That's going to create a stable octet on the I. Think about this concept for a while, for a second at least. K, it lost one electron. Electrons are negative. If I take a negative charge off my shoulder right here, if I take a negative charge off and throw it away, I'm now positive. Take a negative charge off, throw it away, it becomes a positive charge. Think about the iodine. You need brackets. I think about compounds need brackets. It took an electron in. It took one electron and a negative charge. Grab a negative charge, boom. Put it on, boom. It's now going to be -1. Maybe that concept helped you out for figuring that out too. Choice A is definitely the best answer for number 2. Next up, number 3. Which type of bond is present in copper wire? A bunch of copper is bonding together. What kind of bond is this going to be? Copper. There's copper, Cu. Please record the answer in the chat. I have some Cus bonding together. Cu, Cu, Cu. All Cus bonding together. Oh, it's a metal and another metal. A metal and another metal. Metal, another metal. Choice C, never even heard of. Electrovalent. No, no such thing of a bond there. Yeah, metallic bond. 2 metals bond together is a metallic bond. 3 of the best answers, choice D. Next up, number 4, the bond between Br atoms and a Br2 molecule is what? So I have a bunch of Brs just bonding together. You should be aware of the 2 liquids on the periodic table. My element, brown, bromine, is a liquid. The other liquid is mercury. At SDP, you should know the 2 liquids on the periodic table. All right, so 2 Brs bonding together. What's that look like? Br bonded with Br. 2 nonmetals bonding together. Let's take this a step further. How many valence electrons does Br have? 7. 1, 2, 3, 4, 5, 6, 7. This Br has 7 as well. You can see their connection there. 2 nonmetals bonding together. Check out your notes. Check out the little cheat sheet on the back page. 2 nonmetals bonding together is definitely be a covalent bond. When 2 nonmetals bond, they share the electrons. They share 2 valence electrons. That's the sharing of electrons in the middle. 4, the best answer is choice C. 4 is the best answer is choice C. Next up, number 5. Which pair of atoms will share electrons when a bond is formed between them? All right, let me pull up the notes again. Sharing of electrons. Oh, share electrons, share electrons. You can see it's got to be a covalent bond or molecular molecule. You're looking for 2 nonmetals. Which one represents 2 nonmetals? So let's locate these 2. Ba, barium, there it is, metal. I, nonmetal. That's definitely going to be an ionic bond. Metal, nonmetal, ionic bond. Next up, we have Br and Cl. Br, bromine, Cl. 2 nonmetals. That looks like it's going to be a covalent bond. Next up, K and Cl. Find the K, metal, Cl, nonmetal. That's an ionic bond. A metal and a nonmetal, ionic bond. Last up, Li and I. Locate them. Li, lithium, group 1. I, nonmetal. That's a metal and a nonmetal. That is an ionic bond too. Sharing of electrons, gotta be a covalent bond. Best answer is choice B. 5 is B. 5 is B. Metal, nonmetal, sharing electrons. Number 6, talking about which substance contains a polar covalent bond. Oh, polar covalent. We know covalent's 2 nonmetals. Polar, check it out. Polar has a pole for electrons. It's got to be 2 nonmetals. It's going to share electrons unequally. The electronegativity difference is 0.3 to 1.7. It's asymmetrical. So all those must qualify for polar covalent bond. Let's check it out. Let's draw them up. So the first one up is H2. H2, here's H, element number 1. H and H, there's 2 H's. Each H has 1 valence electron. 1 there, 1 there, boom. They're sharing 2 electrons total. This creates a single covalent bond. Within the single covalent bond, you can look at this and you can see that it will be symmetrical. You could cut this thing in half and you will have the same thing on both sides. It's symmetrical. If you look at the electronegativity difference, which you can calculate very easily, some of you guys don't need to calculate it. Some of you guys may want to check out some hard numbers. Check out the next page of the reference table, page 10. Find hydrogen, find the electronegativity for hydrogen, it's 2.2. You have 2.2, and you're subtracting that by 2.2. That's obviously going to give you 0. Look at my little chart at the last page of your notes. Electronegativity of 0, you can see it's right there in the window. That is a non-polar covalent bond. The same thing would be true for Cl. You take 2 Cl's, bond them together. Cl's both have 7 valence electrons. It's in group 17. The sharing electrons, it's going to be a single covalent bond between them. And you take the difference, whatever it is, subtract 3.3 minus 3.3, whatever it is, it's going to have a difference of 0. Again, this thing, if you cut it in half, it is symmetrical as well. That is a non-polar covalent bond. So choice C is non-polar. Choice A is non-polar. You see the Lewis dot diagrams there. Choice D, let's check out choice D. Choice D, you have K and Cl. Let's locate those. K and Cl. There's K. There's Cl. A metal and a non-metal bonded together is an ionic bond. So that's definitely not a choice. Best answer here is going to be HCl. HCl, hydrochloric acid, is a polar covalent bond. Why? You have an H, which has 1 valence electron. You have a Cl, which has 7 valence electrons. See this with the drawing? It is sharing the electrons in the middle to create a single covalent bond, but the Cl is being a hog. It's taking that electron and say, hey, you're with me. I'm going to steal you on in. It's going to pull it on into that direction of the Cl. Polar covalent bond. It's not symmetrical. If you do the electronegativity difference, it's going to be between 0.3 and 1.7. 6, the best answer is going to be choice B. Next up, number 7. Which bond between which 2 atoms is most polar? Polar? Oh, 0.3 to 1.7. The most polar would be closer to 1.7. So the biggest electronegativity difference would be the most polar. So again, use page 10 and 11. Let's go through this. Maybe you want your reference table. Maybe you want your calculator. You definitely want a reference table. Definitely want your calculator handy too. Find your Br and find your Cl. Bromine. Bromine and chlorine. All right, there's chlorine. Electronegativity difference. Electronegativity for chlorine is 3.2 for Cl. Write it on down right above it. For your post-test, I would suggest having some scrap paper handy. Bromine, there it is. 3.0. Oh, 3.0 minus 3.2. That's a difference of 0.2. That's more like a non-polar bond. Next one on up, we have bromine and fluorine. Bromine, there it is again, 3.0. Find fluorine. 4.0. The highest electronegativity value is 4.0. Fluorine, the most electronegative element. This difference is 1.0. Do the same thing for iodine and chlorine. Chlorine, we already have that one, is 3.2. Find iodine. Scroll on down. There it is. Iodine is 2.7. 2.7 minus 3.2. Take that value. And last but not least, let's take the electronegativity difference between iodine and fluorine. Find iodine, find fluorine. Iodine's 2.7. Fluorine is 4.0. We already did that one. Subtract those values. It's a difference of 1.3. Subtract all the values. Which has the greatest electronegativity difference? Choice D. This is going to be the most polar. Again, if you check out that chart, you'll see the most polar is going to be greatest, closest to 1.7. 7, the best answer is going to be choice D. 7, the best answer is choice D. Number 8, the correct formula for sodium oxide is what? Someone says, hey, what's sodium oxide? You could tell them, hey, sodium's Na. Definitely Na. We know that. If you don't know sodium symbol, check on page 10, 11. So it's definitely not choice A. It's definitely not choice B. Sodium's charge, you look at the reference table, its charge is +1. You can see that. Oxide, oxygen, oxide is definitely going to be O. Its charge is, you should know this from redox rules, oxygen's charge is always going to be equal to -2. Then you call up Joseph A, say, hey, Joseph, what do I do now? I have my charges. I don't know what to do with them. And he's going to tell you, I'm going to take those two charges. You're going to take the absolute value and cross. Oh, what's up, Joseph?
Oh, what's up?
Not much. What do you do next, Joseph?
Like you said prior, you just flip it around. So you get
Crisscross.
Na2O.
So if you get stuck with this question, Joseph, watch out. Next Wednesday, some people might be calling you up, but thank you. So crisscross your charges. We now have Na2O1. Take the two charges. You find the two charges. Take the absolute and crisscross those charges. Na2O1. Na2O1. 8, the best answer is choice D. A lot of D's here. 8 is D. Number 9, we got the correct formula for sodium thiosulfate. So this was a binary compound, 2 elements. This is going to be a ternary compound. What's the formula for sodium thiosulfate? Sodium we know is Na. We just looked at the charge for sodium. Let's represent the charge, which is +1. And then you're like, what the heck is thiosulfate? If it is not an element that you're aware of, or if it's not an element on page 10 or 11, you're flipping back to page 2 of the reference table, say, oh, it's a polyatomic ion. So if it's not an element, refer back to page 2 for polyatomic ion, and look for thiosulfate. Thiosulfates, oh, there it is. Last one. When we did polyatomic ions, I told you represent them in parentheses. S2O3, close your parentheses. Don't forget the charge. And I told you it's just like a binary compound, but you got to take those charges and cross them up again. Make sure you have the parentheses. It makes a big difference here. Take the charges and crisscross those charges. Take the absolute value, crisscross those charges. Charges formula is going to be Na2, absolute value, parentheses, S2O3, 1. Which formula is most similar to that? Obviously, the parentheses are not above, but Na2, S2, O3 is going to be choice D again. 9, the best answer, is going to be choice D. Hopefully you remember how to do that. 9 is D. Number 10, which formula correctly represents iron 3 oxide? Iron 3 oxide. So this time we have a Roman numeral within the name. Iron, okay, iron's definitely Fe. If we zoom in on iron, there's two different charges. There's +2 and +3. Which charge is it referring to? That Roman numeral tells you which charge it is. Iron 3. Oh, it's got to be +3. Oxide is oxygen. The charge on oxygen is automatic because it's a redox rule. And there's only one charge for oxygen. It's -2. Take the two charges and take the absolute value and crisscross those charges. The formula for iron 3 oxide is Fe2O3. Yes, I know I'm going through this fast. If there's something you don't remember how to do, check out your notes. I recorded all the lessons throughout the duration of the year, so check out a video or the section of the video that you might need more help with. Number 10, the best answer, Fe2O3. 10, the best answer is choice A. Moving on. 11, given the structural formula for ethine. Hey, we know what ethine is now. Ethine, eth is 2 carbons, ine tells you a triple bond. What's the total number of electrons shared between the carbon atoms? How many electrons are shared between a triple bond right there? That's all this question wants to know. Eth tells you 2 carbons, ine tells you it's a triple bond. In a triple bond, how many electrons are shared between the 2 carbons? Should know there's electron on the ends of the sticks. 2, 4, 6 electrons are shared with a triple bond. There is a question very similar to this on the post test. It's asking you like a double bond question or so. Maybe it's a triple bond question. It wants to know how many electrons are shared in a single bond, a double bond, or a triple bond. Triple bond has 6 total electrons, or 3 pairs. 11, the best answer is A. Number 12, again, very similar question on the post test as well. Which pair of formulas represent an empirical formula and a molecular formula of a compound? So again, what do we know? We know an empirical formula means simplified. Molecular formula tells you the total number of atoms. All right, first choice. Choice A, we have CH2O, C4H6O4. All right, so this would represent the molecular formula, and this would supposedly represent the empirical formula, because that's simplified. First thing I would do is take the molecular formula and see if that simplifies to the empirical. Let's see if it does. So checking out the molecular formula, figure out a common term there. What number goes into each one of those values? And you're saying, oh, a 2. 4 divided by 2 gives us 2. 6 divided by 2 gives us 3. And 4 divided by 2 gives us 2. Those don't match up. It can't be choice A. Next one, choice B. Look at the molecular formula, find a common term. 6, 12, and 6. Common term is going to have to be 6. Divide every value by 6 within that. This would be 1. 12 divided by 6 would be 2 and 1. And then you're like, oh, that does not match up. Nope. Can't be the correct one. That had to be 2. Check out choice C. There's a molecular formula, supposedly empirical formula. Find the common term. And you're like, oh, that's it. They're both empirical. It can't be the right answer. Last one, Choice D. Find the molecular formula, simplify, find the common term. 3 is a common term. 3 divided by 3 is 1. And 6 divided by 3 gives us 2. There it is. Those would work out. Molecular formula, empirical formula would work out for number 12. 12, the best answer is D. 12 is D. Number 13, now we'll get into some math of the unit. More math. It says, what is a GFM of Ca3PO4 gram formula mass? Do you remember how to do gram formula mass? Gram formula mass is basically if this compound jumps on a scale, what would the mass be? Let's review this. GFM, gram formula mass. So you definitely want scrap piece of paper when you calculate this. When we did the GFMs, we went through a couple of things. I told you to rewrite the formula down. Ca3PO4 2. I know I don't have subscripts. When we did the GFM, we said it was the atom. Followed by the atom was the number of moles times the mass for each element within the compound. We looked at calcium, and you told me how many moles of calcium were there. You said 3. There's 3 moles of calcium. And then the mass had to be rounded to 10th place. What's the mass of calcium? Oh, it's 40.1. The mass of calcium is 40.1. We round that to the 10th place. Next up, we looked at phosphorus. I asked you how many phosphorus were there. You had to distribute the subscript value outside the parentheses to everything inside the parentheses. You would know that there's 2 moles of phosphorus. The mass of phosphorus, P, there it is, P, top left corner, would be 31.0. Then we did the same thing for oxygen. I would ask how many moles of oxygen are there? And you tell me that there's 2 times 4, which would be 8. The mass of oxygen is 16.0. Last thing you'd have to do is multiply them and then add them all together. So don't make a silly mistake. Feel free to use your calculator or your phone, whatever you have to use for the post test. 3 times 40.1, 120.3. (31 times 2, 62.0. 8 times 16, 128. This is GFM. Last thing I had to do is add them all together. Add 3 values, add the 3 values together. 120.3 plus 62 plus 128. Add them all together, we got 310.3. 310.3. 13, when you add them all together, 310, that is the best answer. 13, the best answer is, hey, D again. D is the best answer. A few more questions, folks. 14, check this one out. Question 14, given the reaction, how many moles of H2O are needed to exactly react with 2 moles of calcium? All right, it's a stoichiometry type of question. We have this chemical reaction below, and it has a ratio. The ratio in the chemical equation below is going to be 1 to 2, 1, 1, 1, 2, 1, 1. Question says, how many moles of H2O? We're trying to figure out how much water, how many moles of H2O are needed if exactly 2 moles of Ca react. So calcium is going from 1 to 2. From 1 to 2, how do we get there? We had to multiply by a value of times 2. 2. So the unknown, how you can get there? You have to multiply 2 times 2. So this value up here is going to have to be 4 moles of water. You had to multiply it by 2. Calcium, what would you do? You'd multiply this by 2. Every chemical reaction must obey the law of conservation of mass, energy, and charge. So they're all multiplied by 2 for the next reaction to react with it. 14, the best answer is D. Again, 14 is D. 15, question reads, what's the total mass in grams of 0.75 moles of SO2? Oh, you're like, oh, what do I do now? I forgot how to do this stuff. What is the total mass in grams? You're looking for that. 0.75 moles of SO2. That is the important information. Okay, this is definitely a mass you're looking for. Moles you have, and you could have a compound, which you could have the GFM. You could solve for the GFM of that compound. So pull out the reference table, look at the last page of the reference table. Let's figure out what we could use here. All right, mass, mole, GFM. Oh, mass, mole, GFM. We're using the mole calculation. So we have to use the mole calculation for this example. Again, hashtag moles is a formula. Number of moles equals the mass over the GFM. That's it. Plug in what we can. We have number of moles equals 0.75. Mass is what we're looking for. I'll call that X. Oh, we got to solve for this GFM. It's going to take a little work here. We got to solve for the GFM of SO2. So find S and O in the reference table. They're both nonmetals. Oh, there they are. S and O. Solve for the GFM. So the formula is SO2. First thing would be number of moles of S. How many S's do we have? We have 1 mole of S. The mass of S, 32.1. Next up, how many O's do we have? We have 2 moles of O. Mass of O is 16.0. That rounds on up. Take those 2 numbers and add them together. Grams per mole. Plug that in for the GFM, 64.1. Next up, you have to cross multiply. You can cross multiply. Put that over 1. Let's cross multiply this. 0.75 times 64.1 equals X times 0.1. Let's solve this. 0.75 times 64.1. 0.75 times 64.1 gives us 48. Let's see if 48 is an answer. 48. Yeah, choice D. Hey, again, I wouldn't expect the post-test to have all D's for answers. This is randomly just generated, and it scrambles up the answers. Choice D is the answer for number 15. 15 is D. Last question here. What is the percent by mass of nitrogen in NH3? Percent by mass. Oh, percent by mass, percent composition, percent by mass. Mass of part over mass of whole times 100. Percent composition, mass of part over mass of whole times 100. So that's the formula we have to use here. Again, parts over whole times 100. Percent of nitrogen. Percent nitrogen equals parts over whole times 100. Should have got one of those drawing pads with a marker or a mouse. It makes it a lot easier, neater. Been using this mouse all year, so sorry if it's not the best. Percent of nitrogen, the part we have to calculate. So we have to do the GFM again of NH3. Let's find the reference table. Let's do the GFM of NH3. Oh, hydrogen has a mass of 1.0. There's 3 hydrogens. Hydrogen's mass is going to be 3. Nitrogen, there's 1 mole of nitrogen. What's the mass of nitrogen? It's 14. Oh, that was easy. The mass of NO3 is 14 plus 3. 14, 15, 16, 17. The GFM, you could do that on paper if you want to. The mass of NO3 is going to be 17. The whole, bathroom? What's up?
Yes, please.
All right, let me get you pass. 17. The part is going to be the mass of nitrogen. What's the mass of nitrogen? 14. Last up, don't forget to multiply by 100. So throw that in the calculator. Let me know what you get. You got it. This is a GFM. Let me write it out. So someone asked where I got the 17 from. I'm just going to write it out again, where it came from. Let's represent it. So where did the 17 come from? It came from the GFM of NH3. So the GFM for NH3, NH3. I didn't put that on paper. We have how many moles of nitrogen? You have 1. The mass of nitrogen is 14. This equals 14, obviously. How many H's do we have? We have 3. What's the mass of H? Look to the left over here. You're going to notice it's going to be 1.0. So 3 times 1 gives you 3. Add them both together, it gives us 17.0. That's the whole mass. The part, it says mass of nitrogen. So the part has to be this mass right here, 14.0. So 14 divided by 17 times 100. Let's see if we get the same answer. Throw in the calculator, 14 divided by 17, 0.82, multiplied by 100 times 100, 82. So what does that mean? 82% of this compound's makeup, mass, is nitrogen. Choice D is the best answer for 16. 16 is D. 16 is D. All right, you could submit this work. You don't have to. This is a review for unit number 5. We're moving on forward. If there's something you're missing, something you need to review, check out your notes. Check out the recorded lessons. check out the ExaPasses. Maybe you want to YouTube something else as well. Maybe you want to YouTube, oh, how do you calculate GFM, gram formula mass? How do you calculate percent composition? Fine, I don't care. Use your resources that are given to you. All right, so that is unit number 5. Next class, we'll go over unit 6 and 7. That should be Monday. And Tuesday, we should go over 6 and 7, 8 and 9. So 8 and 9 we'll go over too. Unit number 10, hey, we're going through it now. You shouldn't have to recover or go through that again. All right, again, that's unit number 5. Good to go. Let's move it on forward and let's go through organic compounds, naming organic compounds. All right, please open up your guided notes. Let's see where we left off with naming organic compounds. So please open up your guided notes. Hopefully, if you're taking the AP test, you are watching this video and you got that review done. Hopefully that AP test went well too. That's where a lot of people are today, just in case you're live with me now. All right, unit number 10, organic chemistry. We already went through organic basics and hydrocarbons. We went through homologous series. We went through isomers. We're going through topic 4, naming organic compounds. Topic 5 and topic number 6 will not be on the post-test. I probably will go through them, but they will not be on the post-test. I'm not going to rush to get through this by next Wednesday because they're not going to be on the post-test. Topic 4 will be. So unit 1 through unit number 10, all the way to topic number 4 and unit number 10 are fair game for the post-test. All right, organic basics. We talked about organic compounds deal with carbon atoms, which form chain, rings, or networks. Chains, rings, or networks. We talked about carbons have 4 valence electrons. We talked about single bonds saturated. We looked at a butane molecule. Bute told us 4 carbon atoms. Ane tells you they're bonded with a single bond. We looked at a butene molecule, which had 4 carbon atoms with a double bond, which gave us an ending ENE. That's unsaturated. We looked at a butane molecule, 1 butane. The bute tells us that there's 4 carbon atoms. The ine told us that there's a triple bond. Where's the triple bond at carbon number 1? We looked at molecular structures, molecular formulas, which told us the total number of atoms. We looked at structural formulas, told us the shape, the bonding patterns. We looked at condensed structural formulas. We looked at ball and stick models as well. We talked about hydrocarbons deal with an H and C only, hydrogen and carbon only. We talked about some properties for hydrocarbons. We talked about prefixes. Topic 2, we talked about homologous series. Homologous series were alkanes, alkenes, alkynes. Alkanes were single bonds that are saturated. Alkanes, they have a formula, special formula for an alkane series, CnH2n plus 2. We looked at the formulas to figure out if it's an alkane, alkene, or alkyne. So again, anes, enes, ines. A single bond, a double bond, a triple bond for the hydrocarbon. We looked at an isomer. An isomer is the same molecular formula, but a different structural formula. And last class, we started to introduce naming organic compounds, naming straight chain organic compounds. Easy. We looked at butane. We looked at 1 butene. We looked at 2 butene. Straight chain, right across. Very easy. The rest of the class today, we have like 20 minutes to go through it. We're going to figure out how to name a branch chain hydrocarbon. So this section of class with a branch chain, you can see that there's a difference between like straight across, straight carbons across versus like this growth of carbon atoms. So this is going to be a branch chain hydrocarbon. This example right here is the same as the one below. It's the same as this one. It's the same as this one too. By the end of today's class, you'll be able to name this branch chain hydrocarbon. So again, we're using this example for everything for today's class. Naming organic compounds. Now we're going to get a little bit more complex. The straight chains were pretty easy to identify. It's just 1 link of carbons across. And the ending was either ane, een, or ein. That's it. Now we're talking about branch chained. Whoops. Branch chained. So branch chained hydrocarbons. So it's kind of like a tree. You got a tree in the front yard, backyard, whatever. The tree's gonna have a trunk, which would be like the center. It's like the straight chain. And then attached to that are gonna be like branches that come off. Think of it like a tree, a tree. Okay, branch chain hydrocarbon, when carbon atoms are not attached in a straight chain, they're not attached in a straight chain, it's going to be a branch chain hydrocarbon. A little repetitive there. They're not attached in a straight chain. Or there's things branching off. Today we're going to explore some rules for identifying the branch chain. The rules for naming a branch chain hydrocarbon. The first thing you want to do is find the longest continuous continuous is definitely wrong. Looked wrong, but it's not. Okay, longest continuous chain of carbon atoms. First thing you want to do is find the longest connection of carbon to carbon atoms. So the example to the right, how many carbon atoms are connected together? You're looking for the longest link. So the example to the right, we're looking at the carbon atoms. Okay, we have one, we have 2, 3, 4, 5, 6. All right, there's 6 there. Let's try it again. Let's see if this is longer. 1, not connected to a carbon. 2, 3, 4, 5, 6. Okay, there's 6 there. Let's try one more way. 1, 2, 3, 4, 5. All right, so the longest carbon-to-carbon connection is definitely going to be 6. 6 carbons across. This is going to be called the parent chain. Parent chain. Just like you have a last name, came from your parents. Your last name identifies your family. The parent chain identifies how many carbons you're going to have. This situation has 6 carbons across. Okay. Second rule, any group attached to the parent chain is called a substituent group. Any group attached to the parent chain is called a substituent group. Substituent group. So it's like mom and dad, they have a last name. They got married, they have a last name, and then they decided to have some kids. Maybe it's you and your brother, whatever, you and your sister. They're going to branch off of the parent chain. Kind of like a family tree. There's some sort of family tree somewhere in your life. The group attached to the parent chain are called substituent groups. In this situation, to the example to the right, we have a group here. That's a substituent group. And you also have a group here. We're going to identify those groups. These groups are named based on the number of carbon atoms. They contain. So they're going to be named by however many carbon atoms are branched off in that substituent group. We use the prefixes from table P. in the reference table. 1 would refer to meth, 2 is eth, 3 is prop, 4 is but, 5 is pent, so on and so forth. So use the prefixes on table P, and then you add the ending YL. So YL are going to be added to the ending. So the example to the right, let's highlight some stuff here. You don't have to write on yours yet. That right there is attached to the parent chain. Let's represent the parent chain with blue. This is now the parent chain. There's 6 carbon atoms connected to each other. That's the longest parent chain. There's a group attached to carbon number 2. How many carbons are attached there? There's only 1 carbon attached. So there's only 1 carbon attached. This would be called a meth because there's 1 carbon. And then we're not worried about ane, enine. This is methyl. That would be a methyl group. Look below. What's attached? At carbon number 3, you have 2 carbon atoms branching off of carbon number 3. So 2 carbon atoms is referring to right there. 2 is going to tell you in the prefixes, it's F. You add the ending O. Might as well label the parent chain. The parent chain. Labeling this thing, there's 1, 2, 3, 4, 5, 6 carbon atoms, which would be hex. They're all single bonds in between. Therefore, it's hexane. Step 1, find the longest continuous carbon-to-carbon connection. That's 6. Name it, hexane, and then figure out what's branching off of that too. But there's going to be more. I'm going to double-click on this image again. Please double-click on the image. We'll label this. The first thing I'm going to do is figure out the longest carbon-to-carbon connection. In each one of these boxes, I'm going to put the numbers that it's going to refer to. This is carbon number 1. I have to stretch out my boxes a little bit, too small. I would have done this in class on the whiteboard and made the C's on the whiteboard. And inside those, I would represent the number of carbon atoms that there's going to be. It's like a nice little area inside that C to represent what number it is. So carbon 4, carbon 5, and carbon 6. This is the longest continuous chain of carbon atoms. The maximum number of carbon atoms in a chain is 6. Hence, the parent chain is going to be called hex, which is 6. Ane, which tells you single bonds. That's the parent name. My parent name's Brown. My last name is Brown. This would be hexane. What else do we have going on there? We have a carbon branching off of carbon number 2. There's a group up there. This is going to be a methyl group. Methyl. 1 carbon atom branching off of carbon 2 is a methyl. And then below you have 2 carbon atoms branching off of carbon number 3. This would be ethyl. Ethyl. So as you're copying that in, I'm going to restore my screen, refresh my screen. And we're going to add some more to this. We're getting closer to naming this. To the methyl group, we have an ethyl group. We have a hexane too. Okay, cool. All right, so hopefully you could identify the parent chain, name the parent chain. You number the organic molecule, you number the parent chain from the side closest to the double bond or triple bond. So whatever side the double bond or triple bond is, that's how you start to number. If there's no double or triple bond, you number it the side closest to the substituent group. So we did number it left to right, but you can, and sometimes you can number it from right to left. It all depends on where something's branching, where something's happening. Something's happening closest to left. That's why I numbered it from left to right. Okay, next up, the location of the substituent groups. The location of the substituent groups The location of the substituent groups should be shown by numbering the carbon atoms in the parent chain. Should be shown by numbering the carbon atoms in the parent chain. And I already numbered it, so you guys have an idea what I'm talking about for that. So you're gonna have to indicate where there's a group branching off. How do we number? We start numbering from the side from the side closest to a single or double bond or triple bond. We start numbering from the side closest to the double or the triple bond. If there's no double or triple bond present, you start numbering from the side closest to the substituent group. So yeah, you could number right to left. It's not always gonna be left to right. Rule number 5. A couple more rules. Rule number 5. If there's more than one of the same substituent group, there is more than one of the same substituent group, use the prefixes for 2, which would be like a diatomic molecule. Di is 2. Or tri would be 3. Or tetra would be 4. But for this course, we're not going to really focus in on di, tri, or tetra. It's good to know. We don't have to really focus in on those prefixes. But for example, if you want to analyze that, for example, if there was a methyl group on one side of the carbons and one on carbon number 3, carbon on 2, carbon 3, there's both methyl groups there, so it would look something like this. There's a methyl group on carbon 2 and a methyl group on carbon number 3. So if I got rid of that carbon on the bottom and it looks something like this, those would be both methyl groups. So again, this would be a methyl group. Methyl group. This would be a methyl group. This would be 2 at carbon number 2 and 3, 2, 3, dimethyl. Di tells you that there's 2 methyl groups. 2 what? 2 methyl groups. At carbon number 2 and at carbon number 3 are the methyl groups. But that's not the situation right now. Last thing, number 6, let's wrap this on up and name it. Number 6, we need to combine the substituent group. The substituent group needs to be combined with a parent name. Parent name. You're combining the substituent group and the parent name. There is an order to do this as well. First thing up, name the parent group, parent name. Name the parent name. This parent name would be hexane. And then following the parent name would be the substituent groups, the substituent group. And they're going to be listed before the parent name. In alphabetical order. So let's see if we can name this thing now. We were pretty close before. Let's name this organic, this branched organic molecule. All right, the first thing I would do is identify the parent name, which is already hexane. So the name of the organic molecule above is definitely going to be hexane. I put this all the way at the end. It's the last name, just like your last name. It's the last thing you represent. Hex tells you 6 carbon atoms across. Ane tells you single bonds. In this hexane, we have a couple branches going on there. We have a methyl group. We have an ethyl group. I'm going to type one here too before. So scrolling up, we have a methyl and an ethyl group. Alphabetically, E becomes before M, so ethyl is first, followed by methyl. So ethyl, methyl, ethyl, methyl, hexane. But we're not done. We have to indicate where the ethyl group is and where the methyl group is. Ethyl is branching off at carbon number 3. It's 3-ethyl. Methyl is branching off of carbon number 2. That's going to be 2-ethyl. So 3-methyl. Let's do it again. 3-ethyl. So 3 is indicating where the ethyl group is. 2-methyl hexane. There it is. That organic molecule is going to be 3-ethyl, 2-methyl hexane. You just identified and named that branched organic compound. Next class, we're going to go through several more examples. We'll get this with the examples below. We'll understand how to do it. But that's going to be it for today's class. Please make sure you understand how to do units number 1 through units number 10 for the post-test. Please review units 1 through 5. Make sure you master those before we move on forward. You have a lot of time before I see you guys again. This is obviously the last class for the week. I won't see you guys tomorrow. You guys are off from chemistry, so have a great day. Make good decisions. Sorry to ring to the bell. Take care. Make good decisions. Enjoy this weather. Bye, guys.